What if ships could sail over mountains? China didn't ask what if. They built it. Introducing the Gupatan Shiplift, a $7.7 billion mega elevator that hauls 10,000-ton ships, each as tall as a 66-story skyscraper, a jaw-dropping 199 meters into the sky. This engineering marvel is like a floating titan defying gravity itself. But why build this monster in the first place? The answer reveals a master class in strategic thinking that goes far beyond simply moving cargo from point A to point B. China's inland trade faces a brutal challenge: mountains, cliffs, and unpredictable terrain. Nowhere is this challenge more evident than the Wujiang River in Guizhou province, where traditional transport methods are slow, expensive, and often dangerous. The geography here isn't just challenging, it's hostile. Sharp limestone peaks erupt from the landscape like dragon's teeth. Narrow valleys plunge hundreds of meters below. Monsoon seasons transform gentle streams into raging torrents. For centuries, this region was known as the mountain that devours men due to its treacherous passages and deadly landslides. Before the shiplift, moving cargo through this labyrinth of rock and water was nearly impossible. Ships had no path forward. Trucks crawled along crumbling roads, barely holding their ground against landslides. Traditional canal locks, which have worked in other parts of the world, were too slow and impractical for this extreme landscape. A conventional lock system would have required an endless chain of at least 20 separate chambers to navigate the nearly 200-meter elevation change. The economic cost was devastating. Shipping a single container from Guizhou to Shanghai could take up to 2 weeks. It could cost 3 times more than comparable distances elsewhere in China. Local industries suffered. Foreign investment avoided the region entirely. An entire province of 36 million people, larger than most European countries, remained economically isolated. So China did something radical. Instead of forcing the river to adapt to trade, they made trade adapt to the river. That's where the Gupatan shiplift comes in, a machine so powerful it compresses 4 days of travel into just 2.5 hours. Imagine a ship the size of a football field entering a colossal steel chamber. The gates slam shut, sealing it inside with precision-engineered hydraulic doors weighing 400 tons each. Then, the magic begins. Massive pumps roar to life, flooding the chamber with water, cradling the vessel in a liquid elevator. The chamber itself weighs 3,000 tons empty, but with water and a fully loaded cargo ship, this weight balloons to over 11,000 tons. Slowly, the entire structure rises, straight up, as if the river itself is lifting it over the mountain. The ship ascends, climbing higher than the Statue of Liberty and the Great Pyramid of Giza combined. From inside the ship, the experience is surreal. The ground falls away, the world outside shrinking like a disappearing valley. Through small portholes in the chamber walls, passengers can glimpse the shrinking landscape below. River becomes ribbon. Villages become specks. The vast scale of the surrounding mountains becomes apparent only when you're halfway up their imposing faces. When the chamber reaches the upper reservoir, the forward gates open to reveal a new world. A sprawling lake, where just minutes before there was nothing but air. The ship glides forward, continuing its journey as if it hadn't just performed an engineering miracle. It's not just a shortcut, it's a game changer. A river highway carved into the sky. At the heart of this machine is a floating fortress, a colossal ship chamber, 40 meters long and 12 meters wide, holding 500 tons of steel and water. But how do you lift something this massive without disaster? The answer lies in raw mechanical power and surgical precision. The chamber moves along 4 massive concrete towers that function as both guide rails and structural support. These towers are anchored deep into the bedrock, with foundations extending 70 meters below the visible structure. Each tower contains redundant systems of cables, counterweights, and emergency brakes. 256 steel cables, each strong enough to tow a jumbo jet, guide the chamber along a gear rack climbing system. These aren't ordinary cables. Each is composed of 127 individual strands of high-tensile steel twisted together in a precise pattern that maximizes strength. If laid end to end, the cables would stretch over 80 kilometers. Interlocking metal teeth lift the entire structure vertically, like a skyscraper-sized cogwheel. These teeth must engage perfectly on every cycle, with tolerances measured in millimeters, despite the enormous forces involved. The teeth are made from a special alloy that's both incredibly hard yet flexible enough to absorb micro vibrations that would otherwise damage the system. A nut column safety system absorbs the violent shock waves from winds, waves, and even earthquakes. The lift must stay perfectly balanced, even under the tremendous weight of ships and turbulent water pressure. Sensors throughout the structure constantly monitor for the slightest imbalance, automatically adjusting the lifting mechanism to compensate. Counterweights and hydraulic dampers help stabilize the motion, ensuring that even with millimeter-level precision, the system doesn't buckle under pressure. The dampers themselves contain enough hydraulic fluid to fill an Olympic swimming pool and can absorb forces equivalent to a small meteorite impact. The power requirements are staggering. The lift consumes enough electricity to power a small city. Though much of this is generated by the dam's own hydroelectric turbines, backup generators can provide emergency power sufficient to safely lower the chamber. Every cycle is a high-stakes ballet of physics and engineering. One miscalculation, and the entire 10,000-ton mass could slam into the structure with catastrophic force. The control systems feature quintuple redundancy. 5 separate computers continuously check each other's calculations, with any disagreement triggering an immediate safety protocol. Each lifting cycle takes just 30 minutes. In 2.5 hours, an entire mountain range is bypassed. The system can complete up to 24 full cycles per day, moving nearly 5 million tons of cargo annually. A massive shortcut, a game-changer for China's trade routes. But efficiency wasn't the only goal. This project had a far bigger agenda. At first glance, the Gupatan shiplift seems like a futuristic way to move cargo. But beneath the surface, it reveals a much deeper strategy, one that rewrites the economic map of China. For decades, Guizhou province was a logistical dead zone. Its economy was trapped by the same mountains that made transport nearly impossible. Industries struggled. Trade crawled. Entire regions were cut off from prosperity. The province consistently ranked among China's poorest, with per capita GDP less than a third of coastal regions. Now, that's changed. With this vertical water highway, Guizhou is directly linked to China's economic backbone, the Yangtze River. The result? A 5 million-ton freight corridor that slashes costs, accelerates trade, and turns a once-forgotten region into a key economic hub. The numbers tell the story. Since the lift's completion, shipping costs from Guizhou have dropped by 67%. Industrial output has increased by 42%. Foreign investment has surged by 83%. Previously uneconomical industries from advanced manufacturing to agriculture are suddenly viable. A province once known for subsistence farming now hosts technology parks and export zones. Villages that once clung to existence now thrive as service centers for the new shipping corridor. Thousands of jobs have been created, not just in shipping, but in maintenance, logistics, and supporting industries. Tourism itself has boomed, with the lift becoming a destination for both domestic and international visitors fascinated by this engineering wonder. But here's the bigger picture. This isn't just about regional development. It's about fortifying China's domestic supply chains. Imagine if international shipping lanes were suddenly disrupted. Ports close. Sanctions tighten. Global trade grinds to a halt. How does China keep its economy moving? That's where massive inland infrastructure like this becomes critical. The Gupatan ship lift is part of a broader network that includes the Three Gorges Dam, the south to north water transfer project, and thousands of kilometers of inland waterways. Together, they form an internal circulation system, one that can keep goods flowing even if external arteries are severed. This isn't merely speculation. China's dual circulation economic policy explicitly prioritizes developing resilient domestic supply chains that can function independently of global systems if necessary. Projects like the Gupetan shiplift are physical manifestations of this strategy. While the world obsesses over China's skyscrapers, bullet trains, and megacities, it's the hidden supply chains, buried in the mountains and rivers, that might determine its future. These projects receive less international attention but may ultimately prove more consequential. The shiplift also represents a powerful geoengineering approach to climate adaptation. As weather patterns become more extreme, water management becomes increasingly crucial. Systems like the Gupetan shiplift help regulate water flow, prevent flooding, and ensure continued navigability despite changing rainfall patterns. This shiplift isn't just a machine, it's an insurance policy, a chess move in a global economic game, a physical manifestation of China's long-term strategic thinking. So was this built for efficiency or to future-proof China against global uncertainty? The answer increasingly appears to be both. China's Gupetan shiplift isn't just an engineering marvel, it's a statement. A $7.7 billion vertical highway that bends mountains to its will, slashes trade routes, and reshapes entire regions. But it's also just one piece of a much larger puzzle. Similar projects are already under construction throughout China's western provinces. The technology developed for Gupetan is being refined, scaled, and expanded. Future lifts may be even taller, faster, and more efficient. Moreover, this expertise is becoming an export product itself. Chinese engineers who worked on Gupetan are now consulting on similar projects in Southeast Asia, Central Asia, and Africa as part of the Belt and Road Initiative. The knowledge gained from one impossible project fuels dozens more, if China can pull this off. What's next? Because while the world watches their skyscrapers rise and bullet trains blur, it's what's happening beneath the surface, the hidden infrastructure, that might change everything. And if this is just a piece of a larger plan, how far is China willing to go? Let us know what you think in the comments section. If you enjoyed this video, make sure to subscribe and watch our next one shown on screen.